Okay, so this video is going to give you a little bit more practice about graphing by factoring. So say that we have this equation here. We know that this is going to make a parabola just by the look of the equation, but we want to know what it looks like on a graph. So before, what we've done is just kind of made a table. I can just kind of pick some random points for x, and I can calculate what y is going to be. So if I put in -1 for x, I can do -1 times -1 minus 4. Oh, this is supposed to be an x. Minus 4 times -1 minus 32, and I get 27. And I can kind of work through this, and then I could kind of plot my graph. But the problem is, if I go -1, 27, and I go 0, oh, I think this is supposed to be -27, sorry. If I go -1, -27, 0, -32, 1, -35, 2, -36, and these aren't all, notice these aren't all separated by 1, just kind of a pattern. I don't really know where my bottom gets. Like I might get some points over here too, but knowing where my vertex is, I'll eventually get there, but it just takes a really long time plugging in points. So we want to think, well, is there a faster way to get there? Well, we know with these kind of parabolas, and you can kind of just see by the shape of it right now, that when I look at this, if it goes up, it's going to have some spots right here that are some special points. And if I knew what this point was, and I knew what this point was, and I knew what this point was, I could kind of draw a mirror image of it, which is kind of what we figured out when we had that rocket ship problem at the beginning of this chapter. So right here are special points because those are my x-intercepts. And at this point, we know something about these. Well, what do we know about these? We don't know the x value, but I do know that y is equal to 0. So just like plugging in x values into my table, I can get out a y. Maybe if I plug in y is 0, then I can get out an x. Well, if I come over here and I put in y equals 0, and I try to find my x, it gets a little hard to solve this equation for x. So one thing that we thought about is, well, I could just start guessing and figuring out what x might be so that this is 0. Or if I just turn this into a different form, it might be easier to guess. So instead of writing it this way, if I just factor this into, let's see here, 8, 4, and this, okay? This is really the same equation as this, but this one I might be able to guess what will make this 0 a little bit better. Let's see here. Let's try x equals 8. So if I put in x equals 8, 8 minus 8 is 0, 8 plus 4 is 12, 0 times 12 is 0. So that actually does work. So y will be 0 when x equals 8. So I can put that in my table over here. When y is 0, x is 8. There's actually another spot, and if I look over here, well, if I try x equals -4, -4 plus 4 is 0. -4 minus 8 is -12. -12 times 0 is 0, so that one also works. So at -4, 0, that also works. So what I can know from my graph, just looking at that, I know that if I plot just this point and this point, at -4, 0, right here, and 8, 0, right here, and notice this looks like the graph that I kind of guessed about, I've got this here. Well, the only thing is, I know that it opens down. How do I know that? Well, my original equation wasn't negative. But I don't know exactly where that middle spot is, so I'm kind of running into the same issue there. Well, thinking about what we know about these parabolas, it's going to look something like this. And what's special about the shape about these parabolas? Well, they reflect over each other. So there should be a line that I could fold it on, that it would be perfectly halfway through. So if I think about this point, it kind of is going to have to relate to these points here somehow. And it's going to have to be in the middle of them. So if this is -4 spots away from 0, and this is 8 spots away from 0, I wonder what halfway between here is going to be. Well, if I think about it, 8 spots from 0, 4 spots from 0, that's a total of 12 spots from 0. If I split that in half, that's 6 spots from 0. So this needs to be 6 spots away. So 4, so this should be 2. This spot right here would be 2, 0. But I know it's down here. It's 2 something. I just got to figure that out. Well, if I look back in my table, I actually happen to put 2 into my table. And if I didn't happen to, I could just kind of make a table for that. I know the x value, and well, if I know the x value, I can easily find the y. And I had done this earlier. I'd put x equals 2 in for here, done all the calculations, and out came negative 36. So the point is 2, negative 36. And then I have my graph, my 3 points. And now I've graphed my parabola. And it still matches all these other points here. It's just it was a lot faster just to find these 3 points to sketch it rather than guessing and guessing and guessing until I get the right picture. So that is graphing by factoring. Now the question is, what happens when we get graphs that don't factor? Like y equals x squared plus 3x plus 1. Well, if I try to factor this, what numbers multiply to equal 1 but add to equal 3? Well, there aren't any. And actually, if you think about this graph, or if you go to GeoGebra.com or GeoGebra.org, and you graph this, it actually does work. And if you go check this out, figure out, well, why doesn't it factor and where does this work? If you go graph this, you'll kind of see, oh, something happened with my x-intercepts that made it so it wouldn't be graphing. So go check that out if you have questions about that. But just because it doesn't factor doesn't mean that it doesn't have x-intercepts or you can't graph it. There's just something special that happens. Okay, hope that helps. Bye.